Assalamu alaikum. Today I am going to present a video presentation on my thesis work titled A Deep Learning Approach to Analyzing Active Working Hours of Employees. Let's introduce myself and my supervisor. I am Tanvirul Islam, ID 191352779, and my supervisor is MD Shohail Arman, Assistant Professor, Department of Software Engineering. Here is the table of contents of my presentation. In my whole presentation, I will discuss with these topics. Now talk about the background of my research. We all know that most of employees don't give their whole attention in their tasks, and sometimes they waste office hours and also leave the office without informing their supervisor or superior. That's why office cannot achieve the goal in scheduled time, which bring a huge losses for the respective companies. Now talk about the motivation. We want to eliminate needless time loss by employees and detect whether employees are present or absent in their respective desks. And previous researchers used expensive devices, quicker computation time, and less complex operational model is taken in count. Now scope. Employees movement, recognition, and activity inside an office are taken count and creating automated solution to detect it. That's why we gathered real life video for CCTV from CCTV and collected as video data. And with this data, we train our model to contribute in our result. Now talk about the research question. We want to ensure can we use the YOLO-V7 model to more accurately and quickly identify changes, motion, and activity. And also, can we retain the model for each user's financial means? That means, is it users friendly or not? And budget friendly or not? And here is the research gap. Use of expensive devices, no use of advanced algorithm, and not so much relatable task in previous work. And literature review. An author named Carl Casafard published a paper named A Deep Learning Approach to Video Processing for Scene Recognition in Smart Office Environment, which used CNN RCNN and BGC16 for his method, which is not so much updated, and he uses most of the expensive devices, which is not optimized. And I also reviewed some other paper about this literature, about this segment, which is as follows. And now talk about the methodology. Research method are two types. One is qualitative and another is quantitative. My one is quantitative. And here is the data collection methodology. Videos data will be collected from different offices from CCTV footages, and sample size approximately 4 hours, and collected data via CCTV devices. And data will be different type of movement and object data. And data pre-processing methodology. First of all, we gathered CCTV footage and we push it into data pre-processing phase. First of all, then extract the frame and augment and leveling the data for reduce the overfitting problem, and split the dataset into train and validation phase. Here is the labeling of my annotation is as follows. And methodology, whose model is used. And for object detection, YOLO-V7 is used, and for web deployment I use Flask. Model methodology diagram will be as follows. First of all, gather CCTV footages and push it into data pre-processing phase, and after pre-processing with the data, we train our YOLO-V7 model, and train model gives us best PT, last.pt, and epoch50.pt, and more other files. With these files, we loading the model and installing Flask, importing Flask into app.py file, and rendering it into index.html for local host. It is Flask deployment and YOLO-V7 training in at a glance. Now talk about the evaluation method. With the parameter accuracy, precision, recall, confusion matrix, and MAP, mean average precision, I evaluate my model. In every category, we know that, or we saw that there are 90% or above accuracy in my model. For precision 92.3%, for recall 94.7%, and all. And it is the at a glance YOLO-V7 graph. Now result analysis For ELU V7, first of all, we saw that there are at a glance result for all classes and single classes or levels. For precision of all classes, it is 92.3%, recall 94.6%, and for mean average precision, it is 95.7%, which is amazing for our work. And it is the real life ELU V7 output of our model. One is multiple detection and one is single detection, and it is the result analysis using the deployment of Flask. It is our evaluation result of model, and it works fine. It's not working empty dex, it works amazing. Now it's time to talk about the limitation of our research. It is not applicable for any kind of conference room or meeting room. Show less accuracy in blurry environment, cannot generate any kind of ID for creating tracking records, and it is free server deployment. Now future work. We will try to ensure making applicable this model in the large scale and work with more hazy situation for video footages and generate unique ID for each employee with the help of MaxRNN, and deploy our model and creates a shareable link for all. If there are any question, please send me an email for your query, and it's all about my presentation. Thanks everyone. Assalamu alaikum.